Hello everyone, and today we're gonna talk about the fact that Lido goes permissionless. And you will probably ask, hey, come on, everyone can stake with Lido. Isn't it already permissionless? Technically yes, but there's two sides of Lido, and the first one is stakers, and the second one is node operators. And from the node operators side, Lido is definitely not permissionless, not at all. Only curated operators. But this thing is about to change by the end of this year. And today I will tell you about the most exciting parts, maybe from the technical part, that are under the hood of Lido going permissionless. Let me introduce myself. My name is Dmitry. I've been contributing to Lido since the very beginning of 2022. And since the middle of 2023, me and my small team, we are working on the product called CSM, or Community Staking Module. A module to a staking router that will allow anyone to join Lido as a node operator in a permissionless way with the best possible conditions on the market. But how is it to be permissionless? When we think of permissionless staking in Lido between Lido contributors, we have a permissionless trilemma in mind. First of all, a permissionless staking solution should be secure. If it is not secure, no one will use it. At the same time, it should be trustless. Because even if, for example, you would let anyone enter without asking for permission, but then would not allow them to exit, and will say, okay, you need to ask for permission to exit, this solution would not be permissionless. And the last but not the least, it should be attractive. We have such a big market at the moment, so many opportunities for node operators to become parts of different protocols, like Stakewise v3, for example, Rocket Pool, you name it. So the solution should be attractive. And the most complicated part that you cannot focus on one thing. You cannot just make it attractive, or you cannot just make it secure. You need to have it all at the same time. So let's try to find out how we tackle these issues with CSM. And we will start with the first aspect, the trustlessness. And as you can see from the slide, the main tool to ensure trustlessness within CSM is EIP 4788. Have any one of you heard of this EIP? Raise your hands. Oh, not that much. Then I'll give you the gist. So you guys probably heard that Ethereum is actually made out of two parts, execution layer and the consensus layer. And the consensus layer is also known as beacon chain. And the weird thing about Ethereum is that before EIP 74788, the only connection that exists was between the beacon chain and execution layer. So from beacon chain, you can access execution layer data, but not vice versa. However, all the DeFi applications, all the smart contracts, they live on the execution layer. And if your DeFi application is a staking protocol, for example, you need to have this information about things going on with validators on the beacon chain. So with EIP 4788, it now became possible, but not in a very straightforward way. So beacon chain data might be represented in the form of a simple Merkle tree. So you can represent any data that ever exists on beacon chain as a Merkle tree. And EIP 4788 allows you not to directly access this data, but to prove that the data provided is indeed a part of the beacon chain data by proving it against the root of the beacon block. So CSM used this feature to prove two facts: validator withdrawals and validator slashings in a permissionless way. So we can stop here now. Okay, we can prove it. Actually, not all the things are that easy, and there's several challenges. The first challenge is when you want to request a beacon block header or beacon block root we can block root. From the execution layer, you cannot request it by block number. You can only request it by a timestamp, because execution layer could not know beforehand if the slot was missed or not, so it creates a bit of a challenge. You need to operate timestamps, which is not very typical in a blockchain. Second thing is that the data is arranged within this tree concerning so-called G indices, or indices that shows that this particular data is located in this leaf and this particular data is located here. And the problem is that with each hard fork, or with, it can change, maybe not with each, but it tends to change from hard fork to hard fork, meaning that you need to solve this issue somehow, because the data that you rely on might be here, and in the next hard fork, it might be here. The next thing is that you cannot prove simple data, because this proofs might be gamed. You cannot just prove that, okay, in this particular leaf, there's uint. You can do it, but in most cases, it would either be useless or it might be gameable. And the last, and probably the main issue, is that roots of the blocks are only available for 27 hours. So if you want to prove some event that is far, far back, you cannot do it explicitly. Sounds like there should be emoji here, but it disappeared. Anyway, we have solutions for it. So first of all, instead of using these timestamps and trying to catch the correct block and guess if this is the correct block on the correct timestamp, we prove beacon block header first to be sure that we are dealing with the correct block. Second, we maintain a trusted storage for the G indices so that with any hard fork, when new G indices arrive, we can be sure that both previous data and the new data can be accepted in a trustless way. The next thing is that instead of proving simple data types, like for example, validator balance on a withdrawal or the fact of the validator being slashed, we prove the whole validator structure instead, so that we can be sure that this is indeed the correct validator structure and all the data is included. Why it is important? Because it's way harder to fake the data if it is a structure than if it is a simple data type. And the last, even though these block headers are available only for 27 hours, there's still such a thing as historical accumulators, namely historical summaries, that might be used to prove the data against it. Okay, so that was pretty boring, I know. But if you want to get it even more boring and get a hands-on experience with 4788, make sure to scan the QR code. There's a very handy example here. And to be honest, we spent a lot of time with the team trying to figure out all the peculiarities and to find some useful examples. So there's one, definitely check it out. Moving on, the next aspect, security. And security in CSM is achieved by the thing called bond, but not a regular bond, but a bond with the curves, with the special curves. But before we start talking about special curves, let's first talk about the bond in general. So in the case of a vanilla staking, all the stake associated with the validator is just a single pile. It might be either provided by the validator itself or by a third party, but there's no split in it. With CSM, validator stake is split into two parts: delegated stake and node operator's bond. And the main difference between them is that node operator's bond is slashed first. And only when there's no node operator's bond, the delegated stake is slashed. So it's just a security tool to ensure that node operator will behave okay, or even better than okay, and will not put user funds at risk because he also have some skin in the game. Now let's take a look at example. Imagine you have a node operator within CSM operating 4 validators. Each of them has bond, each of them has delegated part of stake. Now something bad happening, for example, huge slashing, but for just a single, for the very first validator, or huge MEV has been stolen by this validator. And the amount of penalty in this case exceeds the amount of bond. What we will see? We will see that now it's not only validator's bond which is affected by this penalty, but also delegated stake. However, we still have these three validators with the bond provided by the same node operator that remained untouched. That doesn't seem to be okay. So let's try to fix it. Instead of using a separate bond for a separate validator, we can now use a concept of a continuous bond. So if you have 10 validators or 4 validators, like in this example, all the bond provided will be treated as a single security collateral. And in this case, even if a single penalty exceeds the amount of bond required for a single validator, user funds would still be out of risk. So it drastically reduces the risk. But can we reduce this risk further and at the same time make it appealing for the node operators to use this technology? Let's try to think about it a bit. First of all, major penalties are associated with the block propose duty. So there's basically two things. When you propose a block, you can either steal MEV or execution layer rewards from the liquid staking protocol you operate with, or you can be a subject of a proposer slashing if you, for example, propose 2 different blocks. However, slashings are likely to be correlated for a single operator because slashing might also happen due to double attestation. And if you run, for example, these 4 validators on a single machine and you have a backup machine, and for some reason your backup machine launches without you knowing, and now both of them perform different attestations, and most likely all of your validators are slashed. However, even though these slashings are likely to be correlated for a single operator, there are very few operators in the whole world, all of them are absolute professionals, who are capable of flipping the midterm penalty, the most dangerous penalty within Ethereum slashing, from 0 ETH to 1 ETH. Meaning that for absolute majority of CSM operators, or I would say for most of them, for all of them, even if the slashing will be correlated, the midterm penalty would still be 0, and there would be no difference in absolute values between individual and correlated slashing. So what are we going to do with all this information? With all this information, we can introduce these curves, our concept of nonlinear bond. So the bond would not only be a common feature for the node operator, so no matter how many validators you have, all the bond is used as a single collateral, but also the bond will be reduced the more validators you have, because this common pile will be bigger and bigger, and you can add a bit less, a bit less, a bit less. And the final value here would definitely be the minimal value required to cover for the minimal possible slashing penalty. At the end of the day, it makes it beneficial for both. It makes it way more secure for stakers and pretty attractive for node operators. Okay, let's move on to the final part, attractiveness. And that's the trickiest part, actually. Because with all these solutions on the market, with things like vaults from Stakewise, with cool features provided by Rocket Pool, with amazing features provided by other staking providers, it is really hard to compete, and it is really hard to offer something new. But we do believe that CSM Performance Oracle is indeed one of the unique features that might be a game changer in terms of attractiveness. But before we dive into the Performance Oracle itself, let's first talk about why we need it. And now let's take a look at rewards. Rewards for Ethereum validators actually came from 2 sources. The first one is simple beacon chain rewards. So you fulfill your validator duties, you get your rewards in a form of reward skimming. All of them are accumulated on Lido withdrawal credentials, a single contract for all Lido validators. At the same time, when you got lucky enough to produce a block, you will also get some part of execution layer rewards, either only priority fees, or in case of using MEV boost, you will also get MEV rewards. And all of them would still land at the same vault within the same huge pile. And the second part is actually really volatile. So if this vault was only for you, you would see the graph of the balance of this vault like slightly changing, increase, slightly changing, increase. Or maybe no increase because you were not lucky enough and slightly change, and again, slightly change. So how to distribute this pile, this whole pile? And the first thing that comes in mind when we talk about a big staking protocol, as big as Lido, for example, or as big as any other protocol on the market, is reward smoothing. We all heard a lot about MEV smoothing pools, about smoothing rewards in general, because the system itself is not made to be beneficial for small stakers, for the people running couple validators. It is made to be apparently, it turned out that it is made for big operators. So why not to let small stakers benefit from being a part of a big protocol? But there's an issue. And the issue is, if we build a permissionless system, we cannot just say that, OK, we have 100,000 participants, and we will evenly split rewards between them. That would not be true. That would never work, because you never know how people would perform since the entry is permissionless. So it would be beneficial only for people actually performing bad, because they will get more rewards than they would get when performing on their own, right? But reward smoothing is still a cool feature. Now let's try to figure out how we can combine these two facts. Imagine we have 5 validators, each of them performing individually. As a performance metrics, we would use the simplest possible thing, attestation rate, ratio between successful attestations and total number of attestations assigned to this validator. Then we will draw a line. We will call it threshold. And what it would mean that any validator with the performance above the threshold is now called good performer. And any validator below the threshold is called bad performer. But what it has to do with rewards. And that's the most interesting part. So if you are a good performer, you will get these socialized rewards. But if you are a bad performer, you will get no rewards at all on a delegated part of a stake. And even though validators below the threshold would still get some rewards for the common pool, they would not get any share of it just because of the fact that they are below the threshold. And these rewards will be distributed between well performers, making this system a very good incentive for people not to be bad performers, but to be good performers, and to get this smooth piece of pie, I would say. So that brings us to the overall concept of the CSM performance oracle. First of all, it uses attestations as the main performance metrics. And it utilizes the performance threshold concept to distinguish bad performers and good performers, to calculate the rewards distribution. But as you might have noticed, we are talking about individual validators. And these calculations are impossible to be done on chain. It will be enormous in terms of gas. So that's why a Merkle tree is used to submit this rewards distribution on chain. And only a root of a Merkle tree is submitted, and then the rewards might be claimed. OK, now let's move back to the initial permissionless trilemma. It turns out that we have just addressed all 3 aspects of this concept by introducing you a new product called CSM. And for me, CSM is the best fit for this trilemma. But if you want to learn more technical details, again, as I've mentioned last time, if this talk was not boring enough and you want to get into even more boring stuff, then go check it out, the discussion about CSM on Lido Research Forum. That was basically it. I'm always available on Telegram for any questions, suggestions. And the final thing, CSM is still under development, but we are about to launch testnet probably within less than a month. And the one last thing. Some say that if someone of you guys sitting in the audience or probably watching the stream is really interested in joining CSM with a small but very pleasant benefit, some say that you need to scan this QR code and get yourself an OAuth. It is some analog of POAP, for some reason called OAuth, no matter. Anyway, go scan it if you want to join both CSM testnet and a mainnet with a little benefit. And that's it from my side. Thank you.
Thank you, Dmitry. We have time for some questions. Yeah, please.
Yeah, thanks for the great presentation. Was very interesting. Just a question regarding the attractiveness. You, as I understand correctly, you basically classify between two groups, right? The operators not good enough, kind of not going beyond this threshold, and the ones kind of performing better than this threshold. Is there any incentive in kind of performing even better? Like, I imagine there's a group then, kind of operators performing maybe good enough, and some maybe have a setup like put a lot of effort in performing really well. Is there any incentive or is there the idea of an incentive to also reward those who are even better than the average good performers?
Thank you for your question. That's a really good question. And the simple answer is no. There is no incentive to perform either at the very bottom, like a bit above the threshold, or at the very top. But the thing is that it is extremely hard to actually maintain your performance not at the very top level, but on some level like 97% precisely. It's really hard. So the reality is that especially solo stakers, they all try to perform as well as possible. They try to maintain their setup. And if they face some issues, some small issues, they should not be penalized for it. However, if they perform really bad, if a participant performs really bad, he should be penalized. But we understand as people who design this module that incentivizing the very top performance might be a good thing. But for CSM, we propose another idea. We propose the idea that you need to be okay, and if you can perform better, you can perform better. It will be beneficial for the common pool, and all of you guys will get more rewards. And we believe that it is extremely hard to keep like at the very bottom, like just technically. So no, there's no incentive to be at the very top. There's an incentive to be at the top batch, but not at the very top.
Any other questions?
Hey there. So you mentioned something that the validators or the operators that can tip the scale, that have enough power, enough ETH to tip the scale to turn the penalty system into the red.
Yes.
Those are not the target of CSM. Therefore, they just won't opt into this system. That makes me think, is it like if they are not incentivized to join CSM, is it because the permission set is more, gives more rewards to the operators than the CSM?
That's a great question. Thank you, Paul. It is really hard to compare CSM with the permission set. Why? Because to join permission set, on one hand, you don't need to put any bond, in terms of in a form of an ETH. But you need to put your reputation at stake, and you need to pass all this process. At the same time, with CSM, you don't need to ask permission. You can simply add funds. So there's two separate ways, and I would say that if you, as a node operator, is actually capable of running that much validators, at the current state of the network, it is something around 12,000 or more validators, then you would probably apply to be a professional operator, or you would maintain the business on your own. You don't need this staking protocol. So for CSM, we are not saying that you are not allowed to enter if you're a big operator. We are saying that huge operators would most likely follow the other path, or their participation within CSM would not be that significant. Thank you, Paul. Do we have time for one last question?
One last question.
Yeah.
How do you see the CSM meaningfully contributing to Lido's decentralization, since only 0.5% will be allocated to it?
Wow, where did you get this number of 0.5%? Probably you are thinking of simple DVT at the moment. Let me clear the picture for you. So from the very start, it is assumed, again, it is to be decided by the Lido DAO. I'm not the person to decide, but it is assumed that CSM will start with 1%. However, again, as you can see from the initial proposal, this cap would be gradually raised, or will be proposed to raised up to 10%, even with the very first version of the code and the security assumptions. But I can assure you that even though CSM version 1 is not released yet, we are already working on CSM version 1.5 or version 2. So this is just the very first step. And I mean, if you are standing on top of the mountain and you want to get to the bottom of the mountain, or vice versa, you cannot do it with one step. You do it with gradual steps. So what you see now is the very first step in a multiple steps. So multiple steps would follow. And I do believe that, again, this is my personal opinion, I do believe that the end game for Lido core protocol might look like multiple versions of CSM with different parameters, so that even curated operators might probably be offered an opportunity to join, like not the curated operators, but pro operators, larger operators might also be offered with the opportunity to join, for example, CSM-like module with a bond. So I would say that in terms of decentralization, this is a very important step, still a very small step, but a very first step in a row of multiple steps.
Thank you for the participation.
Thank you.